Hey everybody, we are back in the lab today and we are going to be working on the exercise bacterial enumeration out of your lab manual. And if you remember, I've already posted a video about serial dilutions. So I went over what they are and how to make them. And then we are going to use those serial dilutions today on two enumeration techniques. We're going to go over the MPN and we're going to go over the pour plate technique. So what we're doing here is we're using our dilutions that we already made, and we are trying to get a count on viable cells. Now that's a key word, is viable, and that means that we are counting cells that are actually living. So with the direct microscopic count, you're going to count cells that could potentially not be viable and viable, so you're getting a complete count. Here, we're only getting a count of viable cells that are actually going to grow, because we're going to put cells into media, and then we're going to let them grow for 24 hours or longer if needed to be longer, and then we are going to get a count of how many cells are there, and of course it's viable cells because those are the ones that are growing. So we're going to start out by talking about the MPN technique, and MPN stands for most probable number, and this test uses probability to predict how many cells are in an original sample within about a 95% confidence interval. So that means that with 95% confidence, we can say that there are about this many cells, or however many our chart tells us. So the MPN technique uses lactose broth. We are going to be counting E. coli cells, and if you can remember from our carbohydrate test, that E. coli ferments lactose. So we're going to actually be using the same exact kind of tubes that we used in the carb test. So phenol lactose. So if you remember, this has the phenol red in it, so whenever the lactose is fermented, the tube turns yellow. This just makes it easy for us to count the positive tubes, because when we go over how to read the results, you're going to see that we have to count the positive tubes for these. Which ones have the viable cells in them that are growing and fermenting the sugar lactose? So that just makes it easy to read. The phenol red is not necessary. You can just use the lactose broth with a Durham tube in it, because remember, when E. coli ferments, it produces the gas, so you look for the gas bubble and growth. But the color just makes it easy for us to do, so that's what we're going to do. So we have the phenol lactose broth. Okay, that's our media that we're going to be using, and it is a setup of 5 tubes in a row. So here's my 5 tubes. Okay, so each row has 5 tubes, and in this scenario, we are going to be having 3 rows of tubes. The point of the MPN is to dilute to extinction. So when you're doing the serial dilution, I already kind of told y'all that you want to go all the way until there are no more cells left. And so that's the point of the MPN, is go all the way down till there are no more cells left. Well, if you have no idea how many cells are in the original sample, you don't know how far you have to go before you reach that extinction level. Now, in this class, I already know that 10 to the negative 10 is going to be enough to where there are no more cells left. So that's why whenever I was doing my dilutions, I went all the way to 10 to the negative 10. And so that's what I'm going to use for my MPN. So that's going to be the last dilution that I do for the MPN. So for my setup for my MPN, this is my 10 to the negative 8 row, 10 to the negative 9 row, and 10 to the negative 10 row. So all of these tubes, I'm going to put in my 10 to the negative 8 dilution into these. I'm going to put a 10 to the negative 9 dilution in these, and then I'm going to put a 10 to the negative 10 dilution in these. And then we are going to see where the bacteria grows, and we're going to count the positive tubes. To inoculate the MPNs, I need my dilution blanks, which I have here. Okay, my dilution blanks, I have my 10 to the negative 2 all the way to my 10 to the negative 10. Okay, 10 to the negative 2, 4, 6, 8, and 10. Those are the 5 that I have in front of me. And I've got my pipetter, okay, because that's what you're going to use to inoculate these because you're pipetting in liquid. So I'm going to use my pipetter and then my pipettes. So here is my, this is the results that I've already got here, so we're going to move those. So this is my MPN setup, okay, and my 8, 9, and 10, okay. So I have a 10 to the negative 8 dilution. Here's my 10 to the negative 8 that I've already made. So I have a 10 to the negative 8, and I have my row for 10 to the negative 8. So I'm going to pipette 1 ml into each one of my tubes, okay? So I'm going to put my 10 to the negative 8 dilution into each one of these tubes, 1 ml, 1 ml, 1 ml, 1 ml, 1 ml, and we're going to see where it grows at. Same thing with the 10 to the negative 10. I have a 10 to the negative 10 dilution, so I'm going to put 1, 1, 1, 1, 1 into here. Okay, and then I'm going to look and see where it grows. Now, I don't have a 10 to the negative 9 dilution. So what I'm going to do is I'm going to make one using what I have. I have a 10 to the negative 8, so what I'm going to do is I'm going to take a 10th out of my 10 to the negative 8 and put into my 10 to the negative 9 row. Since I took only a 10th out, this is making a 10 to the negative 9, okay? So I'm going to put 1 ml, a 10th of an ml, 0.1, and then 1 ml of my 10 to the negative 10, okay? And you do this by using your pipettes, okay? So this is a 5 ml pipette, and here's my 1 ml pipette. And all I'm simply going to do, I'm just going to demonstrate this for you a little bit. I put my sterile pipette in there. I give this a little shake. Want to make sure we got ourselves all mixed up. I'm going to suck up 5 mLs. I've got 5 tubes to fill with 1 ml, so I'm going to suck up 5 mLs. And then I'm simply going to get the cap off if I can. And put in 1 ml each. Now, if you were doing this and you're not very versed in pipetting things, then you could suck up 1 ml at a time and put in. Okay, and there is my 10 to the negative 8 dilution. Then I would keep going. I would take 0.1 out of here and put into here, then 0.1, 0.1, 0.1, 0.1, and then do 1 ml of the 10 to the negative 10. And then I would put this in the incubator for 24 hours at 37 degrees Celsius. This is E. coli that I'm dealing with, so that's where it likes to grow at. And then I would be ready to read the results. So that's what I have here. So this is the one that I actually already did. Okay, for my MPN results, I have to count the positive tubes. And remember, we used phenol lactose. So I'm going to count the yellow tubes. And the MPN is a 3-digit number. So you're going to start counting the next to last row that has all positive tubes. So if I had more than just 3 rows here, this row all has positive tubes, but this row does not. So this row is the next to last row that has all positive tubes. This row doesn't, this row does. So I'm going to start counting here if I had more tubes. Now I only have 3, so you don't have to worry about that, but if that was the case, that's how you would count it. So I'm going to start out with my first row, which is my 10 to the negative 8 dilution. And if you see here, they're all positive. They're all yellow. They're all positive. So I would write down the number 5, which I've already done on the board here. That's my first number. Then my next row, I count the positive tubes. I have 3. Remember, red's negative. So I have 3 positive tubes for the 10 to the negative 9th. So I wrote that. And then my last row, 10 to the negative 10, is all zeros, okay, or all negatives. So my answer would be 0 for that. And remember, that's kind of what we were wanting. We were wanting to dilute to extinction. So I write my 0 down. So my MPN for this is 530. So if you look in your lab manual, anytime you do an MPN, you are going to have a standardized chart that goes with it that you're going to use this MPN number, and it's going to give you a number to go by. So if you look up 530 on that standardized chart in your lab manual, it gives you the number 80. Okay? 80 cells. Now, we have to factor in how much we diluted the sample, because remember, we started out with that E. coli sample and we've diluted it down. So we have to multiply by what is called our dilution factor. And so that's what the DF stands for, is dilution factor. So how much did we dilute the original sample? Well, your dilution factor for an MPN is always going to be the middle dilution, no matter what. So your middle dilution for this set is 10 to the negative 9th. So you're going to multiply it by your dilution factor. Now you want to make sure that you change your exponent to a positive number, okay? Because if you don't do that, does it make sense to have 80 times 10 to the negative 9th cells? No, that's less than 1, so you can't have that. So you make sure that you change your exponent. So 80 times 10 to the 9th cells per 100 ml. Your standardized chart is per 100 ml, so that's what we have to use. That's the unit, okay? And then I want to get it into the correct scientific notation, so I'm just going to move my decimal over once to the left to get 8 times 10 to the 10th. Since I moved my decimal over once, I need to add to my exponent per 100 ml. So that is about how many cells I had in my original sample that I was given. Okay, and again, it is an estimate within about a 95% confidence interval. So that's the MPN technique. Now, the other technique that I did is called, or that I'm going to talk about, is called the pour plate technique. So this is still using serial dilutions. However, it's just a different technique that's used. So for this technique, you need empty Petri dishes, your dilutions, a pipettor and pipettes, and molten agar. It's called a pour plate because you are actually going to be plating out your dilutions, so putting the liquid, the dilutions, into an empty Petri dish, and then pouring the molten agar over the dilution and then mixing, okay? I'm not actually going to do this today because I don't have any molten agar, but all you do is take an empty Petri dish, pipette into the empty Petri dish, pour the molten agar over, and then I put it in the incubator for 24 hours to let it grow up. Okay, so here's my pour plates. Okay, so you can see that there's growth. Now, normally you would have multiple pour plates. So you would have a pour plate for the 10 to the negative 2 dilution. You would have a pour plate for a negative 3, a negative 4, a negative 5, a negative 6, and you would go all the way. Because for a pour plate, we have to have what is called our countable plate. So if I were to take my 10 to the negative 2 dilution, my 10 to the negative 2, and plate it out, put 1 ml onto my Petri dish, pour my molten agar over, and let it solidify, and then let it incubate for 24 hours, when it would come out, you would see that it's completely covered in growth because diluting 100-fold is not enough. Whenever you have millions of cells in an original sample, simply diluting it 10 to the negative 2 or 100-fold is not enough. So whenever I would go to try to read this plate, it would just be covered in colonies. That can't be read. So we have what is called a countable plate. And a countable plate for a pour plate is where you have 25 to 250 colonies, or CFUs. CFU stands for colony forming units. So our countable plate is anywhere between 25 and 250 CFUs. I kind of say this is our sweet spot. This is where we want to be. Anything less than 25 has been diluted too much. Anything more than 250, you can't accurately count that. You're going to have too much human error there. So 25 to 250 is where we want to be. So normally, I would have a plate count. I would have a pour plate for each one of these dilutions going all the way down until I hit that 25 to 250 mark. I'm not going to waste all that media. So I already know what my countable plate is, which dilution is my countable plate. It's either going to be 10 to the negative 7 or 10 to the negative 8. So what I did was I did a 10 to the negative 7 and I did a 10 to the negative 8 pour plate. Okay, so to do the negative 8, I had a negative 8 dilution. Okay, so I have a negative 8 dilution, so I simply put 1 ml of this liquid into an empty petri dish, 2 of them, because in science you always want to do multiples, into 2 plates, pour the molten agar over, let it incubate for 24 hours. To get a negative 7, I used, similar to the MPN, I used my 10 to the negative 6. I took a 10th out, 0.1, and played it into 2 pour plates. So 0.1 into one, 0.1 into the other to make my negative 7. Pour the molten agar over, let it solidify, and then put it in the incubator for 24 hours. So, first I have to see which one's my countable plate. Is it my 10 to the negative 7 or is it my 10 to the negative 8? So, if you look here, you will see that there are hardly no CFUs on my 10 to the negative 8. There's maybe, see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 CFUs or colonies on the plate. And if you notice, there's kind of 2 different kinds of colonies. There's ones that look like normal colonies, and then ones that look like little grains of rice. Those are both the same thing. They're both E. coli colonies, but the difference is where they're growing at in the media. The ones that look like little grains of rice are growing within the media, because remember we mixed this together in with our dilution. The ones that look like regular colonies are the ones that are growing on the surface of the agar. So that's where the difference comes in, but you count both of them. So I only have about 11 CFUs on my 10 to the negative 8s. Here's both my 10 to the negative 8s. They both look the same. So there's not enough colonies on here for me to count. So I'm going to eliminate these. So not my 10 to the negative 8. But my 10 to the negative 7, nice, even, and that looks like that's got about in between 25 and 250 CFUs. Now, under normal circumstances, if I was actually counting these plates, I would use a Sharpie and mark each and every colony and count up all the colonies. I'm not going to sit here with a Sharpie and count all these for you. So I just estimated that these have about 125 CFUs on each plate. So that's what I wrote on the board. So you would normally just record how many CFUs the plate has. So I put about 125 CFUs on the board. So your dilution factor for these is, of course, whichever plate you counted. So I counted my 10 to the negative 7 plate, so that's my dilution factor. So 125 times 10 to the 7th, and then your unit is however much you pipetted into the plate. So I pipetted 0.1 mLs into the plate, so that's going to be my unit. So 125 CFUs, 125 times 10 to the 7th CFUs per 0.1 mLs, and then I'm going to move my decimal over 2 times, so 1.25 times 10 to the 9th per 0.1 ml, and that gives me an estimate of how many cells were in the original sample for pour plates. So pour plates, MPNs, are both ways that you can use to enumerate bacteria, and they're just 2 different methods, but they're both using serial dilution. So you have to know how to do dilutions before you know how to do the MPNs and pour plates.